Okay, so let me share my screen. So can everyone see my screen right now?
Yeah.
Perfect.
Yes.
Okay. Okay, so hi everyone, welcome back again. So today we are going to be RL 103, and today's title is called Smarter Learning, Actor-Critic. And so before we begin, let us create some sort of a vision for our group. And this is more than a study group. And what we are hoping is to build a learning community. And we are hoping to do this in three phases. Right now is phase one. We have weekly sessions, we have open discussions, and we are probably going to have project collaborations. In phase two, and we are hoping to do some sort of a live stream session, and people can watch live or join Zoom discussion. And in the final phase, we are hoping to do some sort of an ecosystem. Basically, this is going to consist of multiple subgroups such as RL, AI, research, or anything in life, or any ideas that you might be interested in. And to make it a bit more concrete, in the last phase, each group will be led by an instructor or lead, and anyone with any expertise in any area can teach and share. And the goal of this is to have a platform where anyone can learn, share, and also lead. And anyone who is good at something can teach, and you can be a learner today and a leader tomorrow. And a small team will help coordinate and support each subgroup. And so now we can talk about today's topic. By the end of this week, you may be able to understand the two projects draft that I gave last week. You can understand the core IR ideas. You may recognize value-based methods, policy-based methods, as well as actor-critic structure. And the goal of today for you is to think about how you may improve the two projects. For example, what is unclear in the draft? What experiments would you add? And what ideas you may add? And don't just understand, start asking questions. And all questions are good questions. And so now we can formally begin today's discussion. And we are going to combine two words which we named them actor-critic. And last week we talked about value-based methods. They are basically evaluating actions. And we discussed policy-based methods, which basically act directly. And the golden question is, can we combine both worlds and get the best of both? And the answer is a big yes. And actor-critic basically means act plus evaluate. So last time we have two rival camps of RL. The first camp claims that we use value-based methods, and the goal is to learn a value function, which may be a Q or a V. And the classic example is deep Q learning, and we evaluate actions, then pick the best action. And the second camp claims to learn a policy network, basically give a state, we output the possible actions. And the early example is the policy gradient. Okay, so now we can move on to the discussion phase, and we are going to start a timer of 5 minutes, and you can ask questions to the AI, and you can present your findings afterwards. So let's begin right now. It's 12:50, and we'll return 12:55.
Yes. Just a silent 5 minutes where everyone feel free to list all your questions in the chat, um, or start researching your own answer to your own question. If you actually find good answer, you can also present it after 5 minutes as well. seems like we don't have too much questions today. Uh, if that's the case, we couldn't learn it today. Uh, wait, uh, okay. Uh, then one thing I want to say, maybe I can quickly update us about the next week. Uh, and the next week. So, uh, let me just quickly share my screen, and I can quickly show you guys. And Kobe, do you have something you want to say?
I don't have anything to say right now.
Oh, perfect. So, actually, Alp actually have something to say. Uh, Alp,
Uh,
have you got demo your code yet?
Yes, if I can have like 5, 10 minutes, I can share.
Oh, okay, okay. That's actually really good. How about this? I'm going to quickly share mine. Anyways, and then for people who want to drop at 1 hour mark, they can. And then, but I will just quickly show you about the um mm, about the next 2 weeks stuff. Okay. Uh, okay, I'm sharing my screen. Just first of all, want to say for the next week we will be talking about the RL uh kind of the RL framework of Minimax that help with building training agents to for complex tasks. Particularly how Minimax is able to achieve uh, the number one most efficient parameter to intelligence ratio in the industry. So they only have like 10 billion active parameter model, and which is with inactive, it's in total it's a 230 billion parameter model. It's way smaller than all other competitors, other people on the market, but they are able to have let's say at least like maybe a top six AI model right now. Uh, and uh, the one of the most effective thing they did behind the scene is the uh, uh, RL based training process. And particularly some of the very interesting things I'm just going to be quickly say here is that um, I'm just going to quickly paste it in our group chat on the topics that we'll be talking about the whoops the next week. And also, Kobe, it seems like you didn't allow people to send public message to each other.
oh, I can do it?
Uh,
Oh, sorry, let me try that. 1 second. Really?
I can only send direct message to you in the Zoom.
Hold on, let me see. Okay, yeah,
If you can,
I fixed it right now. You can send it right now. I fixed it.
okay, maybe that's one reason people didn't ask too much questions. Okay,
Oh,
because they don't see each other asking questions. Okay,
okay.
cool. But let's it. So some of the public posts on Minimax with RL. The things that you can study is going to be here. I just sent in the group chat. Also, at the same time, um, so uh, mm, that's it. And then we will uh, and then the fifth week we'll be talking about a workshop that is we'll be talking a little bit about uh the hard AI framework, just their RL training method for fine tuning, and then they fine tune LLMs. Uh, but it's very similar to next week. And very last for work model. And I'm just saying, we are having a process where every week will have a um. Okay, sorry, I'm back. Uh, I was just saying is that you guys can still hear me, right?
Yeah.
Yeah.
Yes.
Well, I just want to say is that for those of you who are interested in kind of co-learning for the next week's material for Minimax, we can be having a chat. I'm thinking the best time to chat will be like tomorrow afternoon. That will be one time, and another time it's going to be on Wednesday morning. So just wanted to check to see anyone is interested in like tomorrow morning, the Wednesday morning or tomorrow afternoon, both are talking about in New York time. So checking to see anyone who is interested in that. I know me and Help will be doing it. Anyone else who are interested in joining us? If you are, feel free to send your email address to the bottom so we can invite you to uh, the the calendar link for us who will be talking about that study. Or you can unmute right now. You can say hi. If you're interested in doing some co-study.
Uh, Hi, can you see my screen? I guess yes. Okay. So I created some notes for the week 3 PPO. Just I want to quickly go through it, not maybe explain everything, but uh, go through it. Yeah. So it explains like the actor-critic network, the general advantage estimation, and PPO, and also goes over clean RL's PPO line by line, and compares DQN with PPO. And I also have 3 Atari games created for demo. I can also show them to you as well. There is Breakout, there is Pong, and there is another something else. I will show you. So this is for my study. So there are so many math symbols that I am trying to learn, and diagrams as well. So one thing when I studied this is actually on the end. There is a link that's called the 37 implementation details of proximal policy optimization, and there are like 3 YouTube videos here, which are extremely nice. I definitely recommend that if you want to dive deeper. And going back to the notes. So as I said, there is like direct reference to PPO showing which code does what, and it explains as the clipping, the surrogate, etc., and the combined flows. So the most code is here, and you can also understand which line does what. I try to go into deeper, and also definitely the parameters as well, and the loops. It shows here, like you have to also go into details of PPO PY to better understand this. So the 13 core implementation details that's in the paper that came later after PPO is very important, and it actually has implemented in CleanRL's PPO PY. So it also shows which implementation details are implemented where and how. And like what the research is found, and yeah, we are comparing the Q network with PPO. There is one interesting thing. This is the same as last week. Like you can train the train your model, and then you can visualize it in the transfer board where it should be like this. Like you can see the episodic return learning rate. You see learning rate drops because there is a less surprise in the learning data within time. So then, like our basic example was cardball, but Atari and continuous control needs like some additions, mostly on preprocessing pipeline. So it just explains what is required for prepare in the preprocessing pipeline for the Atari specific details. So I mean, you have to convert to grayscale and resize it and repeat action for 4 frames. Like it's kind of a obvious things, but these are extremely important for good working model. And also it explains the parameters and optimizations. So very detailed analysis of this, and here you can see you have to additionally install this autorun, accept autorun license, and you can train like the space invaders, Pong and Breakout with make train breakout, etc. And then you can actually, I can show you just a second. It should be on my, yeah, here. Okay. So this is like the breakout demo for the episode 0, and then here's the breakout demo for episode 1. The of course model gets better and better. And it eventually discovers tunneling, like it just creates a tunnel between bricks and then just passes the ball between the tunnel to like score very fast. So it learns these things from just with reinforcement learning. But the thing is, these demos take kind of time, like 2 or 3 hours. MacBook Pro, it's still running. For example, yeah, I started this before the meeting, and it's still running. So these are my notes here, and there is this like the whole algorithm in a diagram format. And in the end, I put some important papers and blog posts and the code references, etc. And I also like additional to the gymnasium Atari demos, I actually created a working application for PPO, but then I actually after starting reading about RLHF, RLVR, and then world models, maybe this is just a demo. I was when I first did it, I was very excited actually. This is going to be a hackathon project for ARC nano payments. That's going to be next week. I haven't still decided to work on this idea, but like I want to show it to you to get a feedback basically. So what it does is like there are robots. Right now there are no registered robots, just a show arm 101 robotic arm, and the idea is like you simulate the training for different tasks for the robot. And actually, this is a Mujoko environment, a simulation environment, and the robot really learns those things. And the people who trained the robot actually make nano payments, like sub 1 cent payments, to train the robot. In return, they get NFTs. And also, there is this lottery side of this application where if you encounter a TD error, like a big TD error, which is actually a surprise and the robot learns much more out of it, you get a much more NFT, I would say. So it's kind of a lottery in sense like uh, the early users who train the robot earns an NFT, and on top of that, if there is a big TD error, their NFT is some kind of special. So in the end, like you pay like maybe $1 or $2 and contribute to the training of the robot, and then you get an NFT, and whether you have a TD on your training, etc., that depends on the NFT type. And like the idea is, it's a rough idea, of course. Like people can like get the skills for their robots later, like once those skills are in marketplace. And whoever buys these skills, basically the smart contracts distribute depending on the contribution of the users. These are all deployed and working, but I also have like or maybe I need to show this. Just a second. I also have the arm here, but it's not fully constructed. So right now this is learning in simulation. Maybe I can do a sim to real. I don't know. It can be in a real robot. So that's my kind of project for the PPO, but I probably converted to Cosmos and World models. And with that, as a last thing, I also started working on like RLHF, reinforcement from human feedback, and Minimax 2.7. So there are two resources that I enjoyed doing this, which is one is RLHF Loop, should be somewhere mentioned here. One is RLHF book and one is RLVR book. So it kind of goes into RLHF Foundation and then Minimax 2.7 architecture and scale and results. I won't go over this just very quickly. If you are interested, you can go over this as well. Yeah, that's it. This is on a different branch, and we 3 is merged into like main. So week 4, maybe that's week 5 actually. Maybe I I worked on the wrong thing, but yeah. So that's all on my side.
Perfect. Thank you for the presentation. Yeah. Any final questions before we end today?
I still have this question over like critic going over action values because from the books or papers I read, uh, maybe I missed something or there is some edge case where it's more likely to be used. But wherever I look, it mostly says like critic learns the how good the state is
Yeah, critic basically is like a value function, basically.
from 0 to 1. It says like yeah, value function, but the value function works on the state, not like the action space.
Yeah, value
Uh,
works on the state. If it's a queue, there is state action.
okay. So that was my big question.
Any other questions? If no question, then we will see you guys next week, and we'll talk about Minimax stuff and a bunch of some sort of verification of PPO and CISPO, I think. Okay, perfect. Then we'll see you next week. Take care.
Right. Thank you.
See you.
Thank you.